Right there. Today we're going to explore the subject mathematics, understanding how it goes. Many people fear this subject because they think it is something difficult to learn. But I think it's because they've not had enough basic explanation as to how to go about it. So here we're going to begin our lectures to explain the basics, how to link the past to the present and to the future. In any mass level you are in now, you've got to have begun from somewhere. Or if you are now a beginning learner, this is the best place for you to begin to comprehend mathematics, to take away the fear of the subject, and then you develop a strong enthusiasm, a strong love that will let you continue on to pursue higher studies. So, mathematics began with the invention of symbols that will help us count. Most of us are aware of these symbols and we have no problem about them for now. Mathematics is an inherent human capability. We wanted to count. We wanted to solve some basic problem with counting, numbering. Due to that, to enable our numerical issues. And if you've heard by now, you know all this and they are very familiar to most of us. The whole thing need to change from the use of numbers to the use of variables, letters. People see A, B, C, D in mathematics and they wonder, what is that doing in maths also? They ask. I think maths is just about this. Just about these symbols. And so, why do we need something else like an X, a Y, a Z? People do ask, what is the meaning of writing, say, 2x? What is the meaning of that? Others say, why do we have to write maybe 7 minus y? What is the meaning? Until we understand these basics, we cannot proceed further with more mathematical exuberances or activities. So, let us begin. You might have known from some time ago that you were asked to sort of find a number that you put here that adds to this to give this, right? Okay. You had no problem. You were able to figure that out quickly, especially in primary schools. And by now, I don't think you see this as a problem at all. You're even wondering why we should bring that. But when maths move on a little, we write now. What do you see now? We were doing virtually the same thing, asking you to find a number that will replace this letter. That is exactly what you were asked to do here, but here you use your mind. But here you are to find a number which, when added to 7, will give you a 10. The procedure for finding such a number is just by guesswork, purely guessing it from your mind. And if you get it correct, they say you are good. If you don't get it, you are wrong. Now, here too, you could have done the same, except that we find that we needed a much systematic approach to arrive at the answer over here, because more complicated cases are going to come and doing guesswork will be difficult to do. Now, observe this. Whenever we deal purely with numbers, we are doing what we call arithmetics, right? Now, you're dealing with a box and they ask you, what do you put in this box? So that when you add it to 3, you get a 7, right? Now, coming to in a modern society, modern mathematics, we bring a letter. It is just here to hide a number from view, so that you are being asked, what do you put in the place of the letter, so that whenever you add it to this 3, you get a 7. And you can now by now guess that it is a 4. How do we arrive at this without doing guesswork is all that mathematics is trying to bring out in solving these maths. Now, let's go back to arithmetics. Mathematics is the world of numbers, figures, and shapes. So if we needed a rule to solve something, numbers have to determine the rule. Now, look at this. Whenever two numbers add to give an answer, one of the numbers is equal to the answer minus the other addend. This is not something for only these 3 numbers per se. Any 3 numbers such that the addition of 2 of them give a third. There is this understanding between them that one of the addend is equal to the answer minus the other addend. So 4 is equal to 7 minus 3. The same way 3 is equal to 7 minus 4. Now, that makes it 4 is equal to 4. If we get this understanding quite clear, we could go applying it here. That if whatever number that need to be added to 3 to give 7, if the number were to be known, we would have said that that number could have been obtained from 7 minus 3, making us get the number to be equal to a 4. The same way, having letter here makes no difference. It's asking the same question. What do you put in the place of this letter? So whatever is added to 3 to give a 7, that thing is equal to the 7 minus the 3. Therefore, x is equal to a 4. Proceeding further, we will move on to another level of operation. This one is a plus operation. Going on a minus operation, we can obtain something like this for our arithmetic part. Now, we needed an idea from the world of numbers. What do they say here? How do I make an 8 from 3 and 5? You will notice that 8 is equal to a 3 plus a 5. Now, that makes that 8 equal to 8. The same way, we apply the same thing symmetrically and get 3 plus 5, and that gives us both equals to 8. Here too, we go to the same length and say this equal to this and that, y equal to 8. Look at the symmetrical relationship that we've created with this operation of minus. Here we have moved to multiplication in this third row. Two numbers multiply themselves to give an answer. Now they ask us, what do you multiply with 6 to get a 30? And here we come to the modern algebra, which is 6 times r equal to 30. And we refuse to bring the symbol times because we think it resembles one of the letters of the alphabet. And so bringing it will mean we are bringing out the alphabet and not the operation, or it could be ambiguous. So whenever a number and a letter are written joined together like this, we mean that they are multiplying without bringing the actual multiplication sign. So now We obtain an idea from here. If two numbers multiply to give an answer, one of the numbers is equal to the answer divided by the other multiplier. Yes. If two numbers multiply to give an answer, one of the numbers is equal to the answer divided by the other multiplier. So 6 is equal to 30 divided by 5, and 5 is also equal to 30 divided by 6. With this idea, we can go and use it here and say, then the box is equal to 30 divided by 6, and therefore the box is the number 5. This is very systematical. The same apply here, that R must be equal to 30 divided by 6, so R is the number 5. Finally, we work on the operation division. And let's say we are doing 12 divided by 6 equals 2. And let's say they want us to find box, so that when you divide by 6, you will get a 2. Or W divided by 6 equals a 2. So how do you make the difference here? Here we say that 12 equals to 2 times 6, and 12 equals to 12. So a number divided by another to give an answer is equal to the answer multiplying the front number, the dividend, is equal to the quotient times the divisor, and that is a root 2. So applying the idea here, we can say box is equal to 2 times 6, and the number here equal to 12. Same apply here to W equals 2 times 6, and W is the number 12. So these are basic algebraic techniques that we employ in mathematics, and you need to master these before we go to the next lectures. Hope you have enjoyed something here, and you're beginning to understand the link between the past, the present, and the future. Subscribe to this channel as we continue to give you more on this subject.